Hi, in this video I will demonstrate how to define internal grooving picco tool in SolidCAM ToolKit. In this example, as you see over here, there is in the tree two solid bodies already. One is the holder or shank itself, let's call it like this, and another is the tip of the tool. And as you can see, by manufacturer itself, it is already divided by two parts or two segments. One that is for the collision control and another is for cutting material. So what is this first step? So in SolidCAM Toolkit, you need to define all the joints and coordinate systems for each of these two bodies, and I'm going to show you how to do that. Now, before going into this coordinate system definition and giving the relations between them, I would like to give you a piece of advice. Before you start defining any of your turning tools, it is very good, to define the parametric one, and you can look at the coordinate system, how they look for each of the component. And based on this, if you take the same coordinate system orientations on any other 3D model tool, it will work completely fine. So that's what I'm going to do in this case. I have over here one Swiss type machine, and what I'm going to do, I'll just take the tool itself, and as this is like internal grooving, I'll just double click or take it to any station position. I'll just look at the coordinate system that we have. So we have a coordinate system of our shank, and here we have the interesting. We have the Z goes over here. We have the Y goes over here. That's our that will be our insert. And here we have a joint. And what is very characteristic for this is that X is going in this direction, and Z is going in this direction. And I wrongly rotated the face up. It's this side over here. So Y is going up. So the same logic I will apply also to the example that we have it over here. Now, before creating these coordinate systems, I would like to take one note. This tip over here, it's kind of good shape, but it has this round over here feature that might be in some cases, will not generate correct or detect the correct tip because it has the fillet here, and it might be that the center of this fillet will be detected instead. So what we want to do, we want to avoid this situation. So that's what I'm going to do first. So I'm just going to define a coordinate system. Sorry, no, the sketch over here, and just I will convert this entity, and just in additional, I'll just go along that surface. Along that line, I'll just make it collinear, and for this one, I'll say it's construction. And I'll go to my commands, and I'll search for a split, and I'm going to select that particular sketch for it, and I'll cut it. As you can see here, we get the three models. So I will need all of these. I'll just accept it. Right, now I have three solid bodies, as you can see. While this and this one, so split 1 and 3, I'll combine them. So we can go over here and type combine. I will just add it, and now we have the tip, and we have also this one, and this is kind of more regular shape. Now in some circumstances, you can add here the fillet. It will easier find the corner, but in some cases you don't really have to. Okay, it will be completely fine to do it. Right, so let's start with the first step. The first step is create the coordinate system shank. So I'll just go and create a coordinate system here, and that's completely fine to stay there. The orientation, it's correct. It's according to the one in the corner, and this one over here, it's in the middle of the shank. That's okay. The next step is defining the coordinate system of the insert, and I like to first create kind of help entities that will help me in this definition. I'll just create this one. It will help me to define the the coordinate system in this direction. So x, it will go here. It's perpendicular to this plane over here. That should work fine, I believe. Let's see. Yeah, that works good. And then I'll do a right click, recent commands, and I'll go to the coordinate system. And my position over here is this. And then point by x, it's this. And what is important is that the z always goes normal to insert. Y position is irrelevant in this case. Right, so we have this, I'll call it shank. And this one is the insert. And the joint is located at the very bottom of the geometry. So if you have this height of your geometry, so you want to place this point just perpendicular on this surface over here to the distance of the complete height of this tip. So that's where that is. It's right over here. So what I'm going to do, I'll just create a plane. The plane is normal to this, and it is located just, over here. And what I'm going to do, I'll just create a sketch, click on that point that we have, I will convert it so it goes very at the bottom. In this case, it's really perfect. It's really like on that edge, but in some particular examples, this point can be anywhere. It can be maybe over here. Right, now let's go with the recent commands and what I did here. Right, so let's go again, recent commands. All right. Yeah. So now let's go to recent commands and let's go to the coordinate system. So I'll go to the section here. Now pay attention, it's a little bit different. So X, it's still the same direction. So I'll just keep it here. And my Y, it's now very relevant because the joint, it must be in the XZ plane. Therefore, the Y-axis is just perpendicular on the surface. So we kind of get, the XZ plane, for our turning jobs. Right, and this coordinate system, it's our joint. Now we are ready for the export. Now, where we actually export the things, you can go to your SolidCAM and you can do a right click on the toolkit and go to the settings. And inside the settings, you'll find here the default folder, which is, for me, located in a tables metric. For you, it can be any other folder. And this is the place where we are going to store this STLs. So let's start with the shank first. So I'll hide the tip and I'll go save as. I will go to that path and I'll just create, the new folder. I'll call it just like video picco, and I'll do it as STL. Pardon. And in my options, I'll just go with coarse resolution. For the shank, we not need to be fine. Do not translate the output to positive space. This is a must, okay? If you don't do it, it will not be good. And also the output coordinate system, and we then just go with shank. And just for better understanding, I'll just do here shank. Here it is. You can get the rough idea of the STL's resolution that will be generated. If you don't like it, or if you like a different resolution, you can also change the tolerances in the export settings. Right, now I'm going to hide this, and you can also like hide it with the tab key and hide it with Control Shift. And so I'll hide this one, and now we are going to export the insert, and I will do this video picco, and we are going to do again with the STL, and this time this will be an insert. I'll do an option, but instead of course I will just go with fine, and also the output coordinate system, it's insert itself. Right, that's it. I'll just unhide this. I'll go to my project and let's start using this inside the toolkit. So what I'm going to do here, I will define this tool on my back tool post, the one that I have over here. So I'm just going to delete this tool, and I'll take I'll take this holder. So I'll just take this component, copy component, so I have a holder. Here it is. And this holder, I'll just put the round shank, which will be a 3D model, and then I'm going to import it like this. And the next thing is the insert itself. So it can be any of these, doesn't really matter, but you can just follow the procedure. It's just because of the icon, but no matter when, you can just change this 3D model, no problem. So again, with the picco, and then I'll just go with the insert. And here we have one additional parameter, cutter width, that I believe it's 0.5. Let me see. You see it here? 0.53. I believe it's 0.5, but if it's 0.53, that's also okay. Right. Now, as you can see, the icon of the groove is now different based on this selection, okay, and especially if it's a 3D model. So pay attention to that. Right. Of course, you can rename the stuff, okay. So if you want for a later use, but let's see how this looks really. Something seems kind of wrong. Like it's not what we actually expected. I mean, the shank is okay, but this is not there. So why? Because whenever you create or insert the component, it has some default position and orientation, which you can find in your connection, okay? Now, I'll keep this at 0, okay? But before doing that, we need to set up our joint. Where is our joint respecting to our shank? So where we would like, to put our insert. It's here, right? So how to do that? I'll just go to the shank, and here we have this joint. Where it is located, we don't know. Here it is, some very strange position. So we create our coordinate system over here. So you make sure that that CAD model is selected, that you are not in the CAM part. So you need to be in the CAD. So we use one of the very nice fancy feature. It is located over here, this 3 dots button. You click it, and you have here an option, calculate the relation between the coordinate system. So what will happen is that SolidCAM will read the CAD data and get the information between the master coordinate system and the slave coordinate system. So take the shank and the joint. I'll click apply. And you can see that now the coordinate system, it's exactly where we want it to be, with the Y going up. Perfect. Now let's go to the groove, the mounting, and everything should be set to 0. There you go. You have your null point there. Everything is set nice. I really, really like it. Perfect. So let's try to use it in our job. I don't have anything so specifically here, but for this demonstration, it will be completely fine. I'll just create ring. It will not be internal. I don't have any internal geometry, but for this video purpose, I think it will be fine. I'll do it on the back spindle, and I'll just go over here till this one is okay. And tool, I'll choose that one, which is on 34. There you go. And I will do a rough, maybe because the insert is pretty small. I'll just go with a little bit more realistic step over stuff, and finish advanced down only, entire geometry. Let's go to the right, and let's save it. Let's see what kind of toolpath we have here. Not too bad. So let's see. Go to returning. Here we go. Here's our insert. Looks good. There you go. And as you can see, one very nice feature here we have, the SolidCAM didn't completely finish this profile. Why? Because he cannot. We really pay attention on this area over here. So even if I selected the whole geometry, it will not finish it at all. Look. So there is a holder protection basically. I hope you enjoyed this video, and see you in the next one.